All right. Well, it's 9 o'clock, 9:01 now. So, assuming we don't get interrupted, I'm going to go ahead and get started. For those of you who haven't seen me yet, my name's Alex Lambert. I'm the Ohio lead FTA. So, what we're going to be doing here is we're going to be telling you all the stuff you want to do to make sure your robot works good. So, we got 2 slots for this, one at 9 and another one later at, I believe, 10:30. Yes, in room 2. So we're just going to go through this, pause somewhere around mid to late way, come back at 10:30, and then we'll have time for any questions that anybody has. So if you got your questions, save them up for the 10:30 slot. All right, with that, let's get started. All right, so what are the things that can go wrong when you're on the field? Well, there's a lot. Electrical connections, so maybe you got a wire that comes out of your motors, or maybe your battery wire comes loose. If you're using Android devices, you could have loose USB connections. That's always a favorite. Battery power, if your robot just runs out of power or is low battery, that can cause bad behavior. Physical contact could be anything from bumping things out of place. I've seen somebody get their power switch flipped off by another robot before. Your battery could fall out of your robot, seen that before. Your Android phone could fall out from being bumped. Lots of stuff can happen when robots get bumpy. Static electricity, another favorite, especially in the Ohio region. In the winter months, it gets a little cold, and very dry. So static electricity is a big thing to watch out for. Wi-Fi issues. We do communicate via Wi-Fi, and sometimes weird stuff happens with the Android devices, with the SDK, or with the phones themselves. Game controllers. Sometimes you get buttons in the wrong configuration. Sometimes the USB connection has weird issues. Sometimes the controller just breaks. And then, of course, software bugs. The enigma of FDK or the SDK code, team code, all kinds of fun stuff can go wrong there. So it's very common for teams to run into robot issues and just throw their hands up in the air and say, well, this worked before in testing, so we don't know what's going on. It must be the fault of the field here. Taking a there's nothing we can do attitude. And this is particularly strong for issues that are difficult to completely avoid, like static electricity. But that being said, there are always things you can do to make your robot more robust and to reduce the chance of issues occurring or to reduce the impact of issues when they do occur. And teams that adopt the mentality of always trying to improve and always trying to identify things that could potentially go wrong and how to mitigate them, those teams will find themselves having a lot better results than those who throw their hands up in the air and blame the practice field or the competition field or this, that, or the other. Another thing is underestimating the magnitude of the physical contact. It's one thing when you're practicing on your own field and you have complete control over where your robot goes, but you start throwing multiple robots on the field, if we have any more of those in-person competitions that we know so much about, that can lead to a lot of unexpected issues. Of course, even when it's just you, yourself, and you, running into walls can always be a fun way to cause things to go horribly wrong, whether that's through bumping things, dislodging things, or simply discharging static electricity. So what do we do about these? So electrical connections are a good place to start. Being robots, everything is communicated over wires. So what you want to do is take a look at your robot as regularly as possible before competition, during competition day, between matches, and check all of your key connections to make sure none of your connectors are coming loose, none of your connectors are popping out of slots, and that everything is generally tight and managed. Battery connectors, USB cables if you're using the Android devices, any Rev Hub control module connections, your power switch. Another thing you can do is pay attention to the type of connectors you use. A lot of the older style batteries come with the white Tamiya connectors we got pictured here on the right. And these guys are particularly prone to coming loose over time. So there's ways to modify them out and replace them with the more modern Anderson power pole crimp connectors. More things you can do is designing your cable holders to reinforce the connections to prevent wiggling or strain. It's very common for some of the more veteran teams who use the Android devices. to put some type of 3D printed or otherwise jury-rigged mount that kind of locks the USB connection in place so it can't move side to side or front to back. It really reduces the chance of wiggling your USB connection out. To do this, you might also use things like zip ties or rubber bands to more firmly secure or even physically pull the connector into the slot. Another thing you want to do is avoid excessively long cables and wires because these are not only a potential snag hazard on yourself or other robots, but they can also act as unwanted antennas picking up stray wireless signals from the air or static electricity from the nearby other robots or metallic surfaces. USB disconnects, I think, is one of the very most common issues. So I know not everybody's going to be able to upgrade to the new Rev control hubs this year. So for those of you who are still using the Android devices, you're going to need to plug those in with a USB connection. And you may find that this is one of the most frequent errors where you're going along, doing your thing, and all of a sudden you get, can't find Rev hub or can't find motor control or something to that extent. Often that's because your USB has either become physically disconnected or become electrically interrupted. So one of the culprits of these is, of course, USB is not designed to be a super robust high contact connector. With more and more disconnects, reconnects, or just being bumped around, the connector can become loose. You can tell by being able to physically wiggle it in the slot if it's not firmly and securely in place. And sometimes, if it's really bad, you can actually notice the errors on your driver station as you wiggle your cables around. Impacts with things also make that worse. So what can you do? Well, there's a couple things. If you have some spare cables, that can help alleviate the problem when identified. USB cables, fortunately, are not terribly expensive. You can use some right angle connectors if your robot design allows it to kind of transmute the force into a perpendicular direction from the actual connector. Whenever you're debugging or programming your robot, you can avoid extra USB inserts and disconnects by programming using ADB over Wi-Fi, directly connecting your laptop to the Android device, or I believe also your control hub wirelessly. And of course, another thing you can do is keep your softwares and firmwares all up to date because the SDK in particular may get fixes added to improve your USB reliability in the face of a disconnect so that it's able to re-pick up the connection and continue on its merry way. Battery power, always a fun one. You might have a little bit better time of this in a remote play because you're not in so much of a rush, but during a in-person competition, teams are constantly moving between this, that, or the other, whether it's judging in practice rounds or getting between one run and the next run and they're right next to each other. It can be difficult to keep your batteries topped off for both your phones and your robot. If your robot Tetrix or otherwise batteries at 12 volts are low, that can lead to all kinds of fun stuff like slow movement, motors not turning correctly, some motors maybe not turning at all depending on the load and the weight of your robot. And if it's really, really low, it can actually cause your electronics to not work properly if they're not getting the current and voltage they need. So it's a good idea to keep your batteries as charged as is humanly possible, and as well as having spare batteries on the charger to swap out in a pinch. Especially if you're getting into the elimination rounds, a good use of a timeout is to change a spare battery if you need to. Also keep in mind that if you're doing a lot of test runs to optimize your program and driving, that drains your battery. So be sure you got some charging going on in between. There have been known issues trying to set up the configuration on the robot controller if the battery is below a certain voltage. So that can lead to some strange, bizarre issues. And of course, phones running out of battery is not good either because if your robot controller or your driver station run out of battery, well, you're pretty much out of luck. It's interesting for the driver station phones in particular, you are allowed to use an external battery pack to charge your driver station phone. I don't see a whole lot of teams using that, but if you're running into driver station battery problems, one thing to consider. And of course, another thing you have to keep in mind is depending on what your program is trying to do and how many things in your robot you are running at the same time, trying to operate every single motor and servo on your robot simultaneously under high load will cause a very large amount of current to be drawn and do a temporary voltage drop on the battery, which can potentially put your other electronics in danger of a brownout due to the way the power is distributed. So keep in mind that even if the resting battery state looks good, depending on how hard you drive your robot, you could actually drain down to a danger zone. Some more tips. Don't put your phone in the middle of your robot, or if you're using the Rev Control Hub, don't completely bury it in the center of your robot, especially if you're using a lot of metallic pieces. They do communicate wirelessly, and wireless signals do not like going through metal. So as much as possible, you want to try and keep it towards the outer side of your robot, but you do want to keep it protected as well. If you're using an Android device, you're going to want to make sure that the robot controller app screen is visible from the outside, if at all possible. This will help you and your lovely FTA assistants figuring out what the heck is going on when things are going haywire. Some more things you can do. You can reduce the wireless noise coupled in through your cables, USB and otherwise, with lovely things like ferrite chokes or beads, pictured on the right there. Just clamp those onto your cables and they'll help attenuate high frequency signals picked up through the air. They're pretty cheap to add on. And then if you're using USB devices, i.e. the Android phone, you can look into surge protectors as well to help prevent the USB connection from being interrupted from a static shock. Speaking of static shocks, always a fun one because it kind of comes at you when you least expect it. And the way the robots tend to be designed tends to be very likely to induce static electricity. All kinds of things like sweepers, spinning wheels, plastic wheels, holonomic wheels, a whole bunch of stuff spinning and rubbing on the foam tiles, just generating static like a mobile Van de Graaff generator. So you're going to want to be conscious of static electricity when designing a robot. Sometimes, you know, the game design, the drivetrain, or the attachments leave you not much of a choice, but you want to at least be conscious of, you know, the fact that certain types of attachments and drivetrains are more likely to generate static than others, and to be aware of it. Using materials like plexiglass can be great for isolating electronics from your metal frame, but it also has a tendency to collect charge on it. So you're going to want to be careful about how you use that, you know, if you're putting electronics on it, what it's touching, things like that. Like I said, spinning plastic devices, basically Van de Graaff generators, just picking up electrons. So you're going to want to be cognizant of those if you're choosing to use them. Or if you can come up with a good alternative, maybe don't use them. Extra long cables, USB cables, wires, you don't want to wrap those around your frame as much as possible because they're going to act like gigantic antennas and also points of entry for static electricity to jump from the frame of your robot into cables. You're going to want to trim all of your wires and cables to be of a non-excessive, just enough length. You also want to try to avoid running your USB cables next to the power cables to avoid picking up the noise from the power. You're going to want to use decent quality shielded cables whenever possible, and you can also use things like plastic sleeves to further isolate your cables from the metallic frame. Basically, the goal is to prevent any external charge from conducting through your frame and into your electronics via cables. And of course, like we mentioned, you can use ferrite chokes to try and mitigate and absorb these high frequency event charges in the form of static. Physical contact considerations. So you're going to want to design your robot such that it is not going to be easily damaged by impacts with other robots, the field, game elements, or anything else that you might encounter in the wild, wild world of FTC. So that could involve, you know, putting your electronics in places where they're shielded from initial impacts. It can be robustinating your arms attachments and general design so that it can sustain at least some amount of impacts. You're going to want to make sure that there are not gaping holes necessarily in your robot leading directly to your delicate internals. You know, if somebody else has got a attachment grabber arm pokey arm, something else just waving around in the air, and it happens to go inside your robot, bad things can happen. Or even on a simple case, if you've got a power switch on the outside of your robot, maybe someone accidentally presses your power switch. Um, we can't stop the match mid-match just because someone gets their power switch turned off. So it's just going to be a bad time. You also want to make sure that any wires attached to your robot are firmly tied down and secured so that they will not be hanging out as gigantic lasso loops to snare or be ensnared by other robots. If you're using an Android device, you're going to want to strongly consider using some type of screen protector so that even if it does get poked by a robot, that it's not going to scratch up your screen. Because even if the cheaper phones are not that cheap. Consider how your own appendages also may contact robots. Are there wires hanging off of them, or do you have unnecessary thin pokey bits that could get stuck in crevices and holes or poke other robots? Just kind of keep in mind that if you if you happen to get allocated with an in-person match later in the season, that you may still encounter other robots, and you're not going to want to design a robot with complete disconsideration for them. Also, you have to consider about when you're building your appendages, what are the materials made out of? Because the conduction of static electricity is best from metal to metal. So if you put some type of electrical tape or other non-conductive shielding on the appendages of your robot, you can kind of help prevent yourself conducting static electricity from another robot to yourself or vice versa. Another thing to consider. Or just do the edges of your robot on the drivetrain or the chassis, just kind of putting some kind of non-conductive layer on the outside to kind of buffer your robot against the outside electronic world. Wi-Fi interference, always a fun topic. Everybody always thinks they have it, and it's often difficult to tell if you do. You want to make sure that your phones have their cell radios disabled, i.e. airplane mode. Make sure your Bluetooth is turned off as well. If you got parents, friends, or family coming into the crowd, try to encourage them strongly to avoid using their mobile Wi-Fi hotspots during the tournament, as those are going to generate more electronic signals in the same spectrum as the robot's using to communicate. If for some reason you happen to bring a router maybe to the pit and the tournament has not forbidden them, make sure that you're choosing channels and signals that are not going to conflict with the tournament area, and do a quick spot measurement with your phone to make sure that your signal does not, in fact, leak outside the pit. Again, that's a pretty rare situation, but something to keep in mind if you're thinking about it. If you have a lot of teams or robots trying to connect together simultaneously, i.e. In an in-person tournament, or if you've got a whole bunch of teams grouping together to co-opt a use of a playing field for remote play, keep in mind that the Wi-Fi direct pairing system can run into troubles when there's a large number of robots trying to pair simultaneously. It's a lot easier to maintain an existing connection than it is to start a new one. When you're in an area with a bunch of other robots, you're going to want to try and be proactive about your Wi-Fi channels. It's going to pick one by default, but you actually can manually change the channel in the settings on your robot controller. So it's a good idea to pull out a laptop or a phone with a Wi-Fi surveyor, see where all the signals are, and try to pick one that is maybe slightly less occupied than another, if you have the ability to do so. Keep in mind that when you do this, if your phone power cycles, that could change your Wi-Fi settings back to the default. So you're going to want to keep an eye on that as well. One way to make your job a lot easier in doing this, which I think is going to be a lot easier this year with the selection of legal phones, is to get a device with a dual band setup where you got both the 2.4 gigahertz and the 5 gigahertz bands to work with. I've seen some tournaments in the past where teams are having a lot of difficulty in the 2.4 gigahertz range, and as soon as it switches over to 5 gigahertz, everything's nice and smooth. Not to mention that in an in-person tournament with the official scoring system and the tablets and all that, that's all connecting wirelessly, generally over 2.4 gigahertz, and you might see some 2.4 gigahertz audio-video systems as well, Bluetooth microphones or other such devices. So 5 gigahertz is a good way to just dodge that whole issue completely. Game controllers. So obviously the interaction between players and their robots starts with the game controllers. So it's a good idea to make sure you're paying attention to how you use them, what you're using, and that everything's working correctly. It's a good idea to have a spare game controller on hand. If you drop it or something weird happens, you could actually have one stop working. So always good to be prepared. Um, if you're encountering control issues, it may not necessarily be due to your game controller. You might check your ping times between your robot controller and driver station. If you notice a particularly high latency, it could be heavy Wi-Fi traffic, so it might be a good idea to try changing the channels. Or it could indicate that there's a difficulty in communicating between your driver station and robot controller. Perhaps there's a lot of metal in between them. I know occasionally you'll see venues, or perhaps you do it yourself, where you use something like a music stand, a sheet music stand, to mount your robot controller on it. If it's made of metal, it could pose an extra impediment, not necessarily complete blockage, but an extra impediment in communication. So keep an eye on those ping times if you're seeing latency between controls and robot reactions. It's also very common, especially for newer teams, to get a little panicked in the heat of things and mismap their robot controllers. For example, misassigning player A versus player B with the start A, start B. Um, there also can be issues where if you boot up and initialize your controllers and you have inputs pressed or the stick turned to one direction or another, that'll be the new default settings and your robot will suddenly be turning all the time or not able to turn in one direction. So a good solution to that is to unmap and remap the controllers with neutral inputs. Every once in a while, you might get an issue where your driver station won't communicate with your gamepad, and no matter how many times you unplug or replug the USB hub or the gamepad or the USB OTG cables, it's still not working. This could be due to the USB host controller on your driver station phone having given up the ghost due to being abused or overused. The only solution for this is to restart your phone. For this reason, it's a good idea to try and restart your driver station and also usually your robot controller phones between matches as much as possible, just to make sure that all of the connection and communications are in optimal states. Another issue that can happen in the heat of battle is you accidentally tap buttons on your controller, such as the mode button on the Logitech controllers, which causes the swapping between your joysticks and your D-pads, and suddenly it's not operating like you expect it to. Or perhaps you've gripped it a little strongly and you switch the toggle from X input mode to direct input mode, or vice versa. So keep in mind these parts of the controller as well. Of course, I've also seen some teams get a little panicked and simply just pull the connections out of their controllers if they don't have super high strength securing mechanisms. It's a good idea to build a little contraption to hold the wires, connections, and hub together between your driver station Android device and your game controllers to minimize the chance of inadvertent disconnects on the controller end. You'll often see teams bring in a contraption that they can put on whatever their driver station stand provided by the tournament, or in your case at your own home location, which makes it easier to keep all these things together. All right, what else can we do? When you're constructing your robot, it's a good idea to use the latest electronics. If you have not completely read through the game manual this year, the modern robotics equipment has finally been phased out, so we're down to only Rev robotics equipment. So now we've got both the Rev expansion hubs and the Rev control hubs. I will say, although the Rev control hub represents yet another new piece of technology to enter the field, and potentially a source of unknown errors, it also represents an excellent opportunity to remove that pesky USB connection between the robot controller Android device and your robot, which has been a known source of issues. So definitely worth trying out if you can afford it. It's also a good idea to label your electronics modules by serial numbers. I think the Rev hubs, if you use multiple expansion hubs and control hubs, will each have a serial number, and they must be different. So a good idea to put some kind of little spot label on there to tell them apart. When you're putting your power switch on your robot, you want to put that in a location that makes it easy to spot. Good idea to put some extra stuff around it. You're supposed to attach the power switch label, but it might be a good idea to put other things around there, whether it's like yellow-black caution tape, maybe some nice LEDs, some arrows, just something to help it stand out. Because if you're showing up at a venue and a volunteer is trying to figure out where your power switch is, such as an FTA, there's a lot of robots to keep track of, and it can be difficult to impossible to memorize the power switch location for everyone, and then identify which orientation the robot is in the heat of the moment. So make it as easy as possible. Also for yourself, in case you're testing and your robot happens to be going awry and you want to turn it off before you burn out a motor. Also keep in mind that you won't be able to pass inspection if your power switch is inaccessible, so keep that in mind as well. As we mentioned before, you're going to want to manage your cables and wires to prevent inadvertent hookings. Make sure your screens are visible if using the robot controller Android device. And then, of course, keeping spares of critical modules can be helpful as well. I don't know if the rev hubs have been prone to failure yet, but we'll see how it goes. Either way, if you have the resources, a spare is always a good idea. At worst case, if you don't need it, someone else may, and you can make their lives a lot nicer. Robot construction, so electronically isolating. So the game manuals mention the grounding straps to use and grounding your robot electronics to the frame, which is all fine and dandy if you want to keep them at the same potential and prevent sparks between your frame building up a charge and your electronics. However, it doesn't help you if somebody else's robot builds up a charge and then discharges it into your frame and your electronics. So I would say probably a good idea to try and isolate your electronics as much as possible, because I think you're more likely to get shocked by something else than yourself. And if you conduct the robot's frame to the electronics via the grounding strap, you're just going to shock everything at the same time. In the same manner, you're going to want to be careful about how you put your wires attached to the robot. It's very common to route wires through U-channels and things like that. Just tie them on there with zip ties. I would recommend, if you can, putting some kind of insulating tubing or plastic sheathing around them, just to try and put an extra barrier between metal to metal, to avoid conducting static charges or just general wireless noise through your wires. And especially you don't want to wrap any wires around the robot frame in a loop, because then you just make a large inductor, and that's no fun for generating stray signals in your robot and adding extra electrical properties that were not intended. Another fun thing you can do is to use non-conductive robot building materials, such as types of plastic, PVC, or even making your frames out of wood. I've seen some teams make robots out of wood. They're always fun. If it's not metal, it won't conduct a charge, and it won't actually maintain a charge either if you're using wood. So that's a good way to just dodge the whole static electricity problem entirely. Plus, it looks cool if you have a wood robot. Of course, you don't want to make it too skinny, or you might get a splintered wood robot, and that's no fun. If you're mounting things on plastic, be very mindful of the type of plastic you're using, because certain types of plastic sheets, like plexiglass, are basically just giant charge collectors. So you may think you're doing a good job of isolating your robot from your electronics, but if it's just sucking up charge onto the plastic sheet, it's just going to put that straight into your electronics. So be careful on how you mount that, and what materials you're using, and do a little research on what the static absorbent properties of different types of plastics are. And then we mentioned before, the game challenge will kind of influence how feasible this is, but you should try and avoid things that involve sweeping bits of plastic onto the foam tiles in a repetitive motion, as like the classic zip tie sweeper mounted on a metal axle, or use of the Omni wheels. I think the Mecanum wheels might be a little bit better depending on their materials, but again, spinning things, rubbing on the foam mat is always going to be fun times. All right, so we've hit our 9:30 limit here, so we'll resume at 10:30 with the robot programming section. If you guys have any questions so far, be sure to write those down. keep them and bring them for next time. We'll see you at 10:30 in FTC Channel 2. All right, everybody. Thanks for watching. See you soon.